Okay, so let's try this again. So the vocab. Individuals are who or what we're describing. So it could be kindergartners, it could be Americans, it could be Los Osos students, it could be animals of some sort, all cows, or whatever the data is describing. Variables are the characteristic that we're measuring on each individual. So for example, if we were doing cows, it might be the height of a cow, the age of a cow, the weight of a cow. If we were doing, let's say, cars, we're taking data on cars, it might be the age of the car, the brand of the car, the mileage that the car gets based on a gallon of gas, etc. Categorical data is just that. It represents categories. So, for example, flavors of ice cream: chocolate, vanilla, strawberry. Again, I would recommend that you write some of these down if it's going to help you remember. They usually don't take on numerical characteristics, so that's a dead giveaway. However, there's a couple of exceptions where you can sometimes get tricked. One is if you're taking a survey and it says, circle 1 if you drive a Ford, circle 2 if you drive a Honda, circle 3 if you drive a Nissan. And so when that data is collected, although it's numerical, it actually represents a category. One that is a little tricky is shoe size, because it does actually make sense to do math with it, but then again, we could argue that it is categorical in nature. Quantitative data takes on numerical values, so certainly temperature, time, weight, height, age, and it makes sense. Like you can average it, test scores, all of that stuff. So it's usually easy to kind of test the difference if it makes sense to do math with the values and say, could I find an average and does that average make sense? And then the distribution is simply all the data values that we collect, and you typically will look at a distribution graphically. So I'm going to draw a few graphs, or I'm going to actually talk about these graphs below here in a second. So when we're looking at distributions, most often they are actually in a histogram format. And some things that you want to talk about when it says describe the distribution, you can use the acronym SOX to help you remember, and this is what it stands for. So S is for shape, O is for outliers, hint, those definitely stick out. C is for center, and we can talk about mean and or median to represent center, since they both do fall towards the center. And then spread, which is either the range or the inner quartile range, and that's what IQR stands for, is inner quartile range, and we'll talk about that in a little bit and how we actually find it. So, SOX, and I'll ask you this in class, again representing each of those first letters, but that's an easy way to remember and remind yourself how to talk about distributions. So some other ways to describe our graphs are in terms of its symmetry or its skewness. So this first one is definitely symmetrical because I could fold it in half and things would line up left with the right. So if I imagined that fold line, and of course the left and right would be on top of each other. Also unimodal, meaning it has one mode or one highest peak. So sometimes we can call things unimodal, sometimes they might be bimodal. For example, when I'm looking down here at this no pattern one, there's a couple of really strong values that stick out in this graph, and so we might refer to this one as bimodal. It looks like there's two modes, although they don't necessarily have to be exactly the same. So right skewed is if I imagine this being followed with a nice smooth curve. I always think of this as there's a mouse. Here's his big old ears and his little eye and his whiskers. Pretend here for a second that this looks like a mouse, and his tail is on the right. So this shape is right skewed because the tail is on the right. And then here, same thing, if I draw a nice smooth curve around it, this time the tail is on the left. So again, here's my mouse. Pretend. I'm really bad at drawing, so you'll have to pretend all year with my drawings. So this one is left skewed because the tail is on the left. This one down here is simply symmetrical. Again, if I drew a nice curve, it again might be referred to as bimodal, two tall peaks. Here, not really any patterns, kind of all over the place. I'll continue on the next lesson.